Today in the workshop, we're working with the ESP32. We'll see how to set up our programming environment, and then we'll explore the many features of this amazing microcontroller. We've got ESP today, so welcome to the workshop. Well, hello and welcome to the workshop, and today we are going to be working with a microcontroller that is not an Arduino, which is very different from what we usually do here in the workshop. We cover a lot of things here in this workshop using Arduinos. We've also used Raspberry Pis and the occasional other device like the NVIDIA Jetson Nano, but we have really stuck with the Arduino when it comes to microcontrollers. Well, we're moving on here in the workshop. Now, it doesn't mean we're not going to be covering Arduinos anymore, but we are also going to be covering other devices. And I asked a number of you on my forum as to which devices you would like to see me cover, and I got some great answers, but one of the consistent answers was the ESP32. Now, the ESP32, I'm sure you have heard about it. It is a small microcontroller that is priced about the same as a good quality Arduino Uno clone, but this thing has so many more features over the Uno. It runs 10 times faster than the Arduino Uno. It is a 32-bit device as opposed to an 8-bit device that the Uno is. It has a multitude of very versatile I/O ports, including ports like digital to analog ports and touch switches. It is really a very versatile device. So let's go and begin our journey with the ESP32 by taking a look at it, and then I'll show you how we can start working with this amazing little microcontroller. The ESP32 is a dual-core 32-bit microcontroller module that is part of the ESP32 series. Each CPU core can be individually controlled. It can support clock frequencies of up to 240 MHz. The ESP32 has multiple power modes. The device has integrated Wi-Fi, Bluetooth, and Bluetooth Low Energy. The ESP32 has multiple digital and analog I/O pins. The ESP32 is one of the ESP32 series of microcontrollers. This module is manufactured by Espressif Systems in Shanghai. This device is a successor to the popular ESP8266. It was released in September of 2016. The ESP32 is used on many ESP32 development boards. This device has up to 18 12-bit analog to digital converters. There are also two 8-bit digital to analog converters. It has 10 capacitive touch sensor inputs, 4 SPI bus channels. It has 2 I2C bus connections. It also has 2 I2S bus connections. If you're not familiar with I2S, this is a bus that can carry audio. The device also contains 3 UARTs for serial communications. The ESP32 can act as an SD card host controller, as well as a host controller for other external devices like eMMC. It can be an IR remote controller with up to 8 individual channels. It can supply pulse width modulation for driving motors, as well as PWM for LEDs, and there are up to 16 independent channels. It has an integrated Hall effect sensor, an ultra-low power analog preamp, and it has multiple real-time clocks. With all this functionality, most pins on the ESP32 have multiple functions. Please note that some of these functions conflict, so they can't all be used simultaneously. One example is that some of the analog to digital converters cannot be used while the Wi-Fi feature is being used. Now, not all development boards that use this module expose all of the pins, and some of these pins are not recommended for use. Some of the digital I/O pins are input only and cannot provide outputs. Now here's an illustration of the pinout of a typical ESP32 module that uses the ESP32. As you can see, many of these pins have multiple functions. The module that I'll be using in our experiments today is the Node MCU ESP32S board, which is a very popular module available on Amazon, eBay, and a number of other sources. For these experiments, you can also use other ESP32 boards, such as the ESP32 Do-It boards, the SparkFun ESP32 Thing, or a series of ESP32 boards from Adafruit. Whatever board you use, make certain that you observe the pinouts, as they will be different than the board that I'm using. So now let's get to work with the ESP32. Now here are just a few of the many varieties of ESP32 boards and modules that you can experiment. Now this first one over here is the one that I'm going to be using for my experiments today. This is the Node MCU 32S version of the ESP32, and it's a pretty popular board, so if you can get your hands on one of these, I would suggest that I pick this one up over at Amazon. Now it's got on it a micro USB connector so that you can connect it up to your computer and use either the Arduino IDE or another IDE to program it. 2 push buttons, which I will explain the usage of later. And of course the ESP32 module is over here. The pinouts for it are marked on the corners over here. Now, one thing about pinouts is that these boards are all ESP32 boards, but they don't necessarily have the same pinouts. So it's very important when you're using the ESP32 to make certain that you obey the correct pinouts for your module. Now, this module over here is really nice. It's a similar module to this, although it actually has 2 less pins. It has, as you can see, the micro USB connector and the 2 push buttons. It also has an OLED display over here, and this is integrated onto the module. So for IoT apps, this is probably a cool thing to have. On the bottom over here, you can see a small connector, and this is a connector for a LiPo battery, for a 3.7 volt battery, so you can make battery powered projects with this one. Another thing I liked about this is that it didn't have the pins soldered onto it, but it did come with not only the pins, but this little sticker that you can put on the side of the pins to give you the pinouts, and that's really a handy thing to have. Now over here we have the ESP32 cam. Now this thing is so cool that I'm going to be making several videos just on this unit alone. This is a very inexpensive unit. It's about $9 or $10 US for this. And as you can see, it's got an integrated camera. Underneath the camera over here, this isn't the ESP32 module, which you'll see soon is underneath. This is a micro SD card slot, so you can store data from the camera on a micro SD card. And on the bottom, the ESP32 itself. Note that over here it's got a connection for a small antenna. Also note that it has far fewer GPIO pins because several of these are already being used by the camera and the micro SD card. Another thing to notice about this board is it does not have a micro USB connector or any kind of a communications connector. You need to use an FTDI adapter in order to program this. And then finally, this one over here is a SparkFun ESP32 Thing. As with all SparkFun products, it's a very high quality product. It's got a micro USB connector and a jack over here that can be used for a 3.7 volt LiPo battery. It uses a different ESP32 module. The ESP32 on this one is this. It's not in the big metal case. But like most SparkFun products, it's excellently documented, and there are some great tutorials available for this board as well. And so there you go, just a few of the many ESP32 boards that you could be using in your projects. Now, to begin working with the ESP32, we are going to be using the Arduino IDE. Now, the Arduino IDE is not the only way to program an ESP32. In fact, it's probably not even the best way to do it. But it is a comfortable environment for most of us because we are familiar with the Arduino IDE, and this makes it a good way to get started with this new microcontroller. Now, in order to use an ESP32 with the Arduino IDE, we are going to need to add the ESP32 board to the IDE using the Boards Manager. So let me show you how to do that, and then we'll go ahead and we'll run a test sketch, everyone's favorite sketch, just to make certain that the ESP32 is indeed communicating with our Arduino IDE. Now, in order to use the ESP32 with the Arduino IDE, we'll need to install the Arduino IDE Boards Manager for the ESP32. So we'll begin by going to the GitHub page that Espressif has for the Arduino ESP32, and you'll find a link to that page in the article that accompanies this video. Now, what we are looking for is a link to a JSON file. If you're not familiar with JSON, it's a format of text file that is understood by all computers, and in this case contains all the parameters for the Boards Manager. This first one over here is what we want, the stable release link. So copy this link over here. Now go into your Arduino IDE. And in the Arduino IDE, go into File, and then go into Preferences. Now, I've already done this, but what you need to do is you need to paste that into this field, Additional Board Manager's URL. Now, you'll probably find this field empty in your Arduino, so you can just simply paste it in and click OK. But if you find there is an entry there already, place a comma after that entry and paste the link to the new JSON file after that, and then click OK. Once you've done that, you've installed the link to the Boards Manager, but you still need to install the boards. So go into Tools, and then go into Board, and go to Boards Manager. When you're in the Boards Manager, type in ESP32. And you will find ESP32 by Espressif. Now, I've already installed mine, but if you haven't done it yet, you'll have an install button over here. And when you click that, it will install. After that, you may close this. Now, to verify that everything works, go back into your boards again and go and take a look at the list of boards. And you should start seeing, like I do down over here, a number of ESP32 boards. There are quite a few of them over here. And we can now use these with our Arduino IDE. Now, for our experiments today, you're going to need an ESP32 module. Now, you don't need to use the same ESP32 module that I'm using because we'll be doing our connections based upon GPIO pin numbers and not actual module pin numbers. So just observe the same GPIO connections and you will be fine. You'll also need an LED and the dropping resistor for that LED. I use 220 ohms, but any value from 150 to 470 ohms will work fine. You'll need a momentary contact push button switch, and you will also need a touch switch. Now, I'm just using a piece of wire for my touch switch, but you can use a piece of printed circuit board or another metallic device that you can attach a wire to. We'll begin by connecting the GPIO pin number 2 to one side of the dropping resistor. The other side of the resistor will be connected to the anode of the LED. We'll then connect the ground from the ESP32 to the cathode of that LED. We'll connect GPIO pin number 0 to one side of the momentary contact push button switch. We'll connect the ground to the other side of the switch. And finally, we will connect our touch switch to GPIO pin number 4. And this completes the wiring for today's experiments. Now, here is an ESP32 version of the common blink sketch. And I'm sure we all know how the blink sketch works. It's pretty well digital right to an LED pin to go high. You delay it, and then digital write to go low. Now what I've added here is also a serial print, so we can go out to the serial monitor saying hello when the LED goes high or on, and world when it goes off, and there's a half-second delay in between, so there's not that much there to it. Now a couple of things different. The LED pin is pin number 2 because we've attached it to GPIO pin number 2, and you'll notice I've set the serial monitor up to a relatively high baud rate. You'll find for most ESP32 sketches you want to keep it at a high baud rate because this device works much faster than the Arduino does. Now a couple of things about uploading a sketch for the ESP32. It's not quite the same as an Arduino. Now you'll notice on my ESP32, which I have over here, there are 2 push buttons, and they're on either side of the micro USB connector on my device. This push button over here is labeled IO0, and this other one is labeled EN, but in actual fact the EN button serves very accurately as a reset button, and the IO0 button comes into play when you are uploading programs. And so what I'm going to do is I'm going to go through and upload this to my ESP32. Now I'll hit the upload button as before, and it compiles a sketch. And the sketch is right now compiling. You're going to find with the Arduino IDE that ESP32 sketches take longer to compile. Now it says connecting, and what you need to do is you need to hold this button down and watch the screen. Now there it goes. It actually connected. It won't connect until you do that. Now on some models of ESP32 you actually need to hold the button down throughout the whole compiling process, but on this one you don't. And as you'll notice now, our blink sketch is indeed running and we are flashing the light on and off. And so we have completed the hello world aspect. Now we can bring up our serial monitor as well, just to see the print that we have here. And it's a bunch of gobbledygook, which is quite common because it's out of sync. What we'll need to do is hit this other switch to reset it. And there you'll see the hello world in sequence with the blinking LED. And since I've picked pin 2, you'll notice there's a built-in LED as well, this little blue one on my ESP32. Now one other thing I want to note is that if you try to do this compile and get an error message at the end of compiling, you're probably going to get a message about something called serial.py, which is a Python program. And that would mean that this has not been installed onto your computer. Now this seems to be touch and go. I have another Ubuntu machine that's virtually identical to this one in the other room, and it compiled just fine without any problem. But this machine I'm using here did not. And if you run into that, there is a sequence of instructions you can execute at the command line to install all of the Python programs that are required for the board manager for the ESP32. And you will find a link in the article accompanying this video to those instructions for both Linux and Windows and for the Mac. So if you run into that problem, there is indeed a way to solve it. But otherwise, here we have our Hello World example, our Blink example running on the ESP32, and now we can move on to bigger and better things. Incidentally, this is one of the few sketches that you'll see today that I actually wrote myself, and I use the term wrote loosely because it's just a Blink sketch. The other ones we're going to be using are all examples that have been included with the ESP32. Now, one of the key features of the ESP32 that makes it ideal for IoT applications is its built-in Wi-Fi capability. And what we're going to cover next is how we can use the Wi-Fi capability of the ESP32. Now, in order to execute the next couple of experiments, you're going to need to know something about your own Wi-Fi network, specifically its SSID, which is the name of the Wi-Fi network, and your passcode. So, armed with that information, let's go and see how we can get our ESP32 communicating on Wi-Fi. Let's take a quick look at the Wi-Fi capabilities of the ESP32. The ESP32 supports Wi-Fi protocols 802.11, B, G, and N. It operates at 2.4 GHz and supports data rates of up to 150 megabits per second. It has adjustable transmit power up to 20.5 dBm. The ESP32 supports antenna diversity. The GPIO can be used to control an external RF switch, allowing the selection of the best antenna for the situation. In the Arduino IDE, we use the Wi-Fi library to expose the Wi-Fi capabilities of the ESP32. This library supports the ESP32 as both a station or as a soft access point. Now in station or STA mode, the ESP32 is another client of your router, similar to your computer, tablet, or phone. In soft access point mode, the ESP32 is the center of the network, providing connections for external devices like a tablet, phone, computer, or an ESP32 in STA mode. By the way, this is called a soft access point because the ESP32 itself has no direct connection to the internet. In STA mode, the ESP32 gets its IP address from the router's DHCP, or Dynamic Host Control Protocol. In SAP mode, the ESP32 assigns the IP addresses to clients. When used in soft access point mode, you can have a maximum of 5 external clients. Both modes allow the ESP32 to act as a web server, which is a very common configuration. So let's start working with the ESP32 and Wi-Fi. Now to start using Wi-Fi with the ESP32, we're going to use the WiFi scan example, and you can find that quite easily. Just go into Examples and go down to the section for your Node 32S and go and look for Wi-Fi, which is down near the bottom. And you will find Wi-Fi scan among all of these different programs. Here it is over here. Now I've got it open up right now, and as the name would imply, this just scans to see what Wi-Fi networks are available to the ESP32. Now we start off the program by using the Wi-Fi library, which is pretty well used for all Wi-Fi programs with the ESP32. And then in the setup, we set it up as a Wi-Fi station. Remember, the ESP32 can either be a station or an access point. We want to be a station. We also disconnect from the Wi-Fi just in case we happen to be connected to something now, because we don't want to be connected to a network when we're scanning for all the networks. Now the scanning itself is quite simple. We do a Wi-Fi scan networks, and that returns a number, which are the number of networks. And then we simply go and iterate through all of those networks and print them all out, print out the parameters of them, the SSID, RSSI is the signal strength, and the encryption type as to whether it is open or encrypted. And we put that up on the serial monitor. We wait 5 seconds and then do the whole scan again. So it's a very simple program. Now I've already uploaded it to my ESP32, so let me open up my serial monitor. And I will reset my ESP32 because you'll usually get gobbledygook when you get that. Now, you will notice that I'm finding 4 different networks in this first scan. Now I've found 5. The 2 networks of interest to me are WJNet24, which is the one I have downstairs here in the basement alongside the workshop, and WJNet24EX, which is up on my 2nd floor. It's another Wi-Fi access point I have in the house because I don't get a very good signal on the upper floors. The rest of these networks, these Videotron and Virgin ones, are just networks that my neighbors have, and as you can see from the signal strength, they're at a much lower signal strength. And so this is a very simple program, and you should have no problem getting it to work. However, one thing you need to know about the ESP32 and Wi-Fi is that it initially can take quite a bit of current to get started. You may get an indication of a brownout, and if you do, try replacing the cable that you're using, the micro USB cable, with a shorter one or with one that has heavier gauge wire. You can also power your ESP32 from an external 5 volt or 3.3 volt power supply if you're having problems getting it to work with your cable. But otherwise, this proves that the ESP32 Wi-Fi is functioning in my environment. Now this Wi-Fi example configures the ESP32 as an access point. In other words, it is providing a Wi-Fi signal for external devices such as tablets, phones, computers, or even another ESP32. And in this particular example, what we're going to do is have a very, very simple web page that we will find at the address 192.168.4.1. And on that page, we'll have two links, one to turn on the LED and one to turn off the LED. And as you recall, we have an LED already connected to GPIO pin number 2, which is also the built-in LED. Now, a couple of parameters here you might want to modify when doing this. First of all, the SSID of our new network is going to be your AP, and you can change that to anything that you like. The same deal with the password. Right now, your password with a capital P is the password, and you can change that as well. Now, if you want to eliminate the need for a password, on this line over here where we set up the soft access point, simply provide just the SSID and eliminate the password. Same deal for the IP address. By default, it'll be 192.168.4.1, but you can change it by inserting another IP address in over here. In the loop, we set up a fairly simple web page, and the web page just has a couple of links to turn on and off our LED. And of course, you could style this and make it into a fancier looking web page, but for the purposes of our demonstration, it will work. Now, if I go over to my tablet and go into Wi-Fi, you will notice I'm already connected to your AP, and I've provided the password, etc. And so let's go into our web browser. And let me just refresh that. And you'll see we have two links over here. Click here to turn on the LED and click here to turn it off. And so I've clicked and I've turned on the LED. And I've clicked to turn it off. And it's very simple, but this is an excellent example of how you can remotely control devices using the ESP32 as a Wi-Fi access point. Now, the final Wi-Fi sketch that we're going to be looking at today is the simple Wi-Fi server sketch. And this sketch does pretty well the exact same thing as the previous sketch does. It creates a web page and allows you to turn on and off an LED. Now, the difference with this one is that in this case, the Wi-Fi is connected in station mode or STA mode. So it does not provide an access point. Instead, it uses your router. So in order to configure this sketch, you're going to need to know your router name and the password for it. The other thing about this sketch is it was set up to work on pin number 5, and so you'll need to modify a couple of things to make it work on pin 2, or simply just move the wire over to GPIO number 5. Now over here you're going to need to put the SSID, that's the name of your Wi-Fi network, and over here you'll need to put your password. Now the thing about modifying this to use pin number 2 instead of pin number 5 is they did something a little bit odd in this sketch. Instead of using a constant or variable to represent the pin, they've actually hard-coded it, so you need to change it in 3 places. So here in the pin mode statement, you'll need to change that to a 2, and also down near the bottom over here, there are 2 places you'll need to do it here, both on these digital writes, which turns the LED on or off. Otherwise, the actual loop is very similar to the previous sketch. It just builds a very simple web page that looks identical to the one in the other sketch. And connecting to the Wi-Fi in station mode is also very easy. It's just this statement over here, Wi-Fi begin, and you pass it the SSID and the password that you need for your network. Now, I've already configured this, but what you need to do with this sketch is when you start it off at first is you need to go into your serial monitor, and in your serial monitor you will see the IP address that has been assigned to it. This is going to pick up an IP address from your network's DHCP servers, so it'll be different on your network than it is on mine. You'll need to make note of that, and then you can go over to a web browser somewhere on your network, even on the same machine you're working on, and go to that particular address. And at that address, you'll get basically the same web page we had before to turn the LED on or turn it off. And so when you click over here, you will turn the LED on, and clicking over here will turn it off. And so it functions identically to the previous sketch, but in this particular case, the Wi-Fi is a client on your network. Now, one of the advantages that the ESP32 has over its predecessor, the ESP8266, is that the ESP32 is capable of Bluetooth, including BLE, or Bluetooth Low Energy. So let's go and take a look to see what it is we need to do to work with Bluetooth on the ESP32. Let's take a quick look at the Bluetooth features of the ESP32. The ESP32 has both classic Bluetooth and BLE, or Bluetooth Low Energy. The ESP32 can act as a Bluetooth client or as a server. You'd use classic Bluetooth for continuous data streaming. BLE can be used for short bursts of data. There are Arduino libraries for Bluetooth and BLE that are installed by default when you install the ESP32 Board Manager. Some uses for classic Bluetooth are wireless headsets, file transfers between devices, wireless keyboards and mice, and wireless audio devices such as speakers. You would use Bluetooth Low Energy, or BLE, for devices like medical monitors, fitness bands, Internet of Things sensors, and also devices like iBeacon, which do targeted promotions. So now let's work with Bluetooth on the ESP32. Now, to demonstrate the use of the classic Bluetooth, we're going to look at the serial-to-serial BT sketch. And this is a sketch that basically ties the serial monitor on your Arduino IDE to the Bluetooth serial. So basically anything that is received via Bluetooth is going to be displayed on the serial monitor, and anything that you type in and enter on the serial monitor will be transmitted via the serial Bluetooth. Now, it's a fairly simple sketch. Most of the work is done by the Bluetooth serial library, and we create an object called serial BT, which represents the Bluetooth. And as you can see from the sketch, it's basically just tying the serial monitor to the serial Bluetooth. Now, there is one parameter that you may wish to modify. Serial BT.begin, where you start the Bluetooth, has the name of the Bluetooth device. And you can change this to any name that you want. And this is the name that you'll identify the device when you're connecting via Bluetooth. So I'm going to start the program right now, and I'm going to open up my serial monitor, and I'm going to reset my device. And it says the device is started, and I can now pair it with my Bluetooth. Now, in order to use this, I've installed the serial terminal onto my Android device, and I have a link in the article that accompanies this video so you can install the same serial terminal. There's also a link in there to a similar device for iOS, so if you happen to have an iPhone or an iPad, you can also use it as well. And I'm going to open this up right now, and in the terminal I'm going to go and look for devices. And here is ESP32 test. I'm going to connect to it, and I've connected to it. So now I'm going to type something. And a very misspelt hello, which we can now see up on my serial monitor. And if I type something in the serial monitor, you will see that that has appeared on my terminal, so I can communicate back and forth between the two of them. So it's a very simple example, but it's an effective method of seeing how serial Bluetooth works with the ESP32. Now, of course, the Wi-Fi and the Bluetooth capabilities of the ESP32 are the things that most people talk about, but as you saw at the beginning of the video, the ESP32 has a myriad of other features. It has all sorts of I/O ports, both digital and analog. It has touch switch inputs. It even has a Hall effect sensor built into it. So what I wanted to do right now is just go through some more of the example sketches using some of these additional features of the ESP32. Now remember, you can take these example sketches and use them as part of your own code when you're designing for the ESP32. And so let's go and take a look at a variety of different ESP32 features. Now, the first of the extra examples we're going to be working with today is one called Simple Time, and I'll show you where I find this as well as all of the other examples I'm going to be using. So we go into File, into Examples, and scroll down to our ESP32 section, and you will find another menu called ESP32, which brings up this sub-menu. And you'll notice a number of things: analog out, camera, chip ID, etc., etc. This is where all the extra examples are, and the first one I'm using is called Simple Time, and it is under the Time section. So let's take a look at that. Now, Simple Time is a sketch that is very powerful. You'll recall that the ESP32 has a built-in real-time clock, and this sets the real-time clock by going out to the internet, querying a network time protocol server, getting the exact time in GMT, converting it to your local time, and then displaying it. So that's quite powerful, and as you can see, there's not a great deal of code required to accomplish that. Now, you're going to need to modify a few constants to get this to work. The first one, SSID. So this is the SSID, or the name of your Wi-Fi network. So you'll recall that I had a number of networks, and the one WJNet24 was the one I had downstairs. So that's what I would enter over here. Make sure to observe the correct case. The same deal for your network password, and you will enter the passcode or password that you use to get onto your Wi-Fi network, and that of course is unique to your own network. The next constant you will want to modify, that you probably will need to modify anyway, is this one that says GMT offset. Now this is how many minutes, or actually how many seconds, you are offset from GMT time. Now in my case, I need to modify this. I'm in Eastern time, and if you're in Eastern time, the value is negative 18,000. This value can be positive or negative depending on whether your time is plus or minus GMT. And I will give you a link in the article in the DroneBot Workshop website that accompanies this video that you can use to calculate the offset for your area. So in my case, I changed this to negative 18,000 because I'm in Eastern time. Now the daylight offset is for areas like the one that I live in that observe daylight savings time, and this generally will be set at 3600. There are 3600 seconds in an hour, and on daylight savings time, our time is offset by an hour. If you do not observe daylight savings time, such as residents of Arizona or Hawaii or Saskatchewan, you would set this down to 0. And so after you modify all of that, we'll take a quick look at this sketch over here. Now, the sketch, really the heart of it, is a function that is built in called config time, and you pass the parameters that we just passed to it, including the NTP server, the daylight offset, and the GMT offset, and it basically configures the clock. Print local time is a function they've defined over here, which gets the local time and then prints it using a format that is defined over here. The Wi-Fi connection is just over here where we connect to the Wi-Fi. And basically that is really it. We disconnect from the Wi-Fi afterward, and then in the loop we go, and every second we go and call the print local time function. So this should cause the time to come up once a second on our serial monitor. So I've already loaded this onto my ESP32, and the version I loaded had my adjustments for my SSD, my password, and my offset of negative 18,000. So let's go and take a look at my serial monitor right now and see what we've got. Now, as usual, we've got a bunch of gobbledygook. I'll hit the reset key, and there we are. And it's printing the time, and if you look up in the corner of my computer, you'll notice that the time does indeed match the time on my computer. So it has gone to the network, got a network time protocol server, and is now just repeating this every once per second. And so there you go, a very simple way of setting the clock on the ESP32. One of the many features of the ESP32 is it has an integrated Hall effect sensor. This is a sensor that can detect the presence of a magnetic field. Now, if you're not familiar with Hall effect sensors, I did do a video and article specifically on these devices, and you can check it out to learn more about them. Now, as you can see from the Hall sensor sketch, this is a very, very simple sketch. It literally has only one statement in here, which is Hall read, and that reads the value of the Hall effect sensor, which we then print out to the serial monitor. Now, the value of the sensor is going to be relatively high when there is no magnetic field, and it'll go very low, in fact below zero, when a magnetic field is picked up. So let's go and open the serial monitor. And let's reset our device. And as you can see, we're getting a series of numbers. Now I'm going to come in with a magnet. And as you can see, those numbers get very, very low. They actually go below zero at this point. And removing the magnet brings them back up. And you can use this in your sketch to determine the presence of a magnetic field near your ESP32. Now, this is an example called LED software fade, and as its name implies, it fades the brightness of an LED. Now, with the Arduino IDE and the ESP32, you cannot use the analog write function. The analog write function for the Arduino drives pulse width modulation, and that can be used to change the brightness of an LED or indeed the speed of a motor. Instead, there is a separate function for driving an LED with pulse width modulation, and it's called the LEDC write function, and that's what this sketch uses. Now, what it does is it sets up a timer and a base frequency for the pulse width modulation, and then they've created an LEDC analog write function, which is essentially the equivalent of the analog write function in the Arduino. And this is used in the loop to vary the brightness of the LED. It goes dims and fades and dims. It just goes through a loop and goes through a number of different values. And so I've already loaded that up to my sketch. And so let's take a look at it right now. And as you can see, the LED is fading now. I'm going to dim the lights over here because it's a little easier to see the LEDs. So there it goes down and up. And as you can see, it's on a fading pulse thing. And so if you're trying to control the brightness of an LED, you can use this sketch as an example for your circuit. The repeat timer example is an example of using the built-in hardware timer on the ESP32. It's a timer that increments every second, and it can be stopped by using the push button that we wired to GPIO pin number 0. Now, this example sketch again is a very good sketch to use within one of your own sketches if you need to do a timing function. So I've got the timer running right now, and we'll open up our serial monitor. And I'm just going to reset our ESP32. And here you can see timer 2, 3, 4, 5. It's giving the time. It'll continue to increment until I hit the button. And then after that, that will stop the timer. And I can reset it again to demo that again. And we're starting again. If I hit the push button, it stops the timer. So again, this would be an excellent sketch to incorporate into one of your own designs if you do indeed need a timer function that you control externally. Now, 10 of the GPIO pins on the ESP32 are also designated as touch switch inputs, and they're designated as touch 0, touch 1, all the way up to touch 9. And they're very simple to use. Now, as you recall from our schematic, we simply attached a wire to a plate or some sort of device we can use as a touch pin. And on my circuit board, it might be a little hard to see, but I've got just a piece of wire looped up over here, and this effectively is my touch switch. and it's connected to GPIO pin number 4, which is also touch pin number 0. Now, as you can see from this sketch, it's very easy to use the touch switch. You simply do a touch read and tell it what pin you're going to, and it will bring you back a value, an analog value, and you can use that value to determine whether the switch has been touched or not. Now, you'll notice the value will go down whenever the switch is touched. So I've loaded this already to my ESP32. I'm going to open my serial monitor and we'll reset it. And we're getting values of around 57 over here. Now let me go and touch the switch. And you'll notice now it drops 21, 18, 17. If I remove my finger, it's back up to the 57. And so we can use these values to determine whether one of the touch switches has been touched and create a very simple interface or keyboard for our project with the ESP32. Now, as I mentioned just a few moments ago, there are so many aspects to the ESP32 that I couldn't possibly cover them all in one video. So I guess I'm going to need to make several more ESP32 videos. And I am looking forward to doing that. It's a device that we're going to use in many projects, including IoT projects, of course. And I also want to make use of that really cool ESP32 cam board. And so to find out about these videos, the best way is to be subscribed to the channel. And if you haven't done that already, you could do that right now by hitting the subscribe button below this video or clicking on the robot that you see in the bottom corner of the video, and he'll do the subscribing for you. Now, when you do subscribe, please hit the bell notification, and that way you will be aware every time I release a new video on the ESP32 or on a multitude of other subjects that I'm sure you'll enjoy. Now, if you want to know more about the ESP32, you'll find an article that accompanies this video on the dronebotworkshop.com website. And there's a link below the video to that article where you can grab the code that I used and also learn a bit more about this amazing processor. Now, as I said at the beginning of the video, this was a topic that was suggested to me by the folks on the DroneBot Workshop forum, and that's the place to go if you want to suggest new topics or participate in polls that I occasionally give in order to find out what topics interest you the most so that I can make videos and articles that you will enjoy. And so please, if you haven't signed up to the forum, go ahead and do so and join the crowd over there. And finally, there's one more thing to sign up for, and that's the newsletter. It's my way of keeping in touch with you and letting you know what's happening here in the workshop. And so once you've done all that signing up, there are plenty more videos on the channel. You can go and watch them right now. And until we meet the next time, please take care of yourselves. And I do hope to see you again soon here in the DroneBot Workshop. Goodbye for now.